What if I told you that everything you can see, every galaxy, every star, every world, is connected in a single vast web that stretches across the entire universe? What if this web resembles something astonishingly familiar, something you carry within your own skull? The universe is not scattered randomly through space. It is organized into the most magnificent structure that has ever existed, and tonight, you and I are going to journey through it together. We are going to explore the cosmic web, and by the end, you will never look at the night sky the same way again. Are you ready to see the universe as it truly is? For most of human history, we looked up and saw stars scattered like sand across a dark beach. Random. Chaotic. Beautiful, yes, but without pattern or purpose. We saw individual points of light, not realizing they were distant island universes like our own Milky Way. And we certainly could not imagine that these galaxies, billions upon billions of them, are arranged in the most spectacular structure the cosmos has ever created. But now, after decades of mapping the heavens, we know the truth. The universe has a skeleton, an architecture, a web of light and matter that defies comprehension, and you are about to witness it. Imagine you could step outside of everything. Outside your room, outside Earth, outside our solar system and the Milky Way. Imagine you could rise above the local group of galaxies, above the Virgo Supercluster, and keep going. Higher and higher, until billions of galaxies appear below you like cities seen from an airplane at night. What would you see? You might expect a uniform fog of light, or perhaps complete chaos. But what actually reveals itself is something so unexpected, so eerily beautiful, that astronomers stood in stunned silence when they first glimpsed it through their data. You would see threads, filaments, slab. This is the cosmic web, and it is the largest known structure in the universe. Spanning the entire observable cosmos, it is a network of galaxy filaments separated by enormous voids of near-perfect emptiness. The filaments themselves are chains of galaxy clusters and groups, rivers of light flowing through the darkness. Some of these cosmic threads stretch for hundreds of millions of light years, connecting distant regions of space in ways that seem almost intentional, almost designed. And yet, this pattern emerged naturally from the laws of physics, gravity, and the mysterious influence of dark matter. The universe organized itself into this magnificent tapestry. Why does the universe look like this? Why a web and not some other pattern? The answer takes us back to the very beginning, to the first moments after the Big Bang. In that primordial fireball, tiny quantum fluctuations created regions that were ever so slightly more dense than others. As the universe expanded and cooled, gravity amplified these differences. Matter began to clump together, drawn into the denser regions. But the universe was also expanding rapidly, stretching these clumps into elongated structures. Over billions of years, galaxies formed along these threads of slightly higher density, while other regions became increasingly empty. The result is what you see now. A cosmic web. When we map the positions of millions of galaxies, measuring their distances with exquisite precision, a pattern emerges from the data like a photograph developing in a darkroom. Computer screens fill with glowing points, each representing a galaxy like our own. Milky Way, each containing hundreds of billions of stars. The points cluster together, forming chains and sheets and knots. Empty regions appear as dark gaps. Scientists have spent decades creating these maps, using some of the largest telescopes ever built. What they have revealed is almost impossible to believe. Structure so vast that light takes billions of years to cross it. A pattern so complex yet so organic that it defies simple explanation. But here is what makes this truly extraordinary. The cosmic web is not just a pattern we observe. It is the fundamental organization of all matter in the universe. Every galaxy, including our own, exists within this structure. The Milky Way is part of a filament. We live inside the web. Right now, as you listen to these words, you are a part of this vast architecture. Your atoms, forged in ancient stars, are participating in the largest structure that has ever existed. You are not separate from the cosmos. You are embedded within its very framework. Does that change how you see yourself? Does it change how you see your place in existence? The scale of the cosmic web is difficult for human minds to grasp. We think in terms of meters and kilometers, perhaps even light years if we are astronomically inclined. But the filaments of the cosmic web measure hundreds of millions of light years in length. To put that in perspective, imagine traveling at the speed of light, the fastest possible velocity in the universe. You could circle the entire Earth 7 times in 1 second. You could reach the moon in just over 1 second. You could travel from the sun to Earth in 8 minutes. But to traverse just one typical filament in the cosmic web, that journey would take you 100 million years, even at light speed. The scale is humbling. Beautiful. And yet, for all its immensity, the cosmic web is also delicate, fragile. The filaments are not solid structures, but rather higher concentrations of galaxies and dark matter. They are like roads that galaxies tend to follow, pathways carved by gravity through the expanding universe. If you were to travel perpendicular to a filament, you would quickly enter a void, a region of profound emptiness. The web is mostly nothing. Void. The galaxies are concentrated along thin threads that occupy only a small fraction of total space. In a sense, the universe is more defined by what is not there than by what is. The voids shape the web as much as the filaments do. Emptiness gives structure to existence. Let us now journey closer to one of these cosmic filaments and explore it in detail. Imagine we are approaching a thread of the web, one of countless billions that span the universe. From a distance, it appears as a soft, glowing line against the darkness, like a contrail left by an aircraft at sunset. But as we draw nearer, that single line resolves into something far more complex. What seemed like a simple thread is actually a highway of galaxies, each one a vast city of stars. Hundreds of them, thousands, all following the same general path through space, bound together by invisible threads of gravity and dark matter. This is not a barren highway. This is a river of creation. Each galaxy in this filament is a world unto itself. Spiral galaxies spin gracefully, their arms traced in newborn blue stars. Elliptical galaxies glow with the warm light of ancient suns. Irregular galaxies tumble chaotically, still bearing the scars of past collisions. And between the galaxies, the space is not truly empty. It is filled with thin wisps of hydrogen gas, heated to millions of degrees by the gravitational energy of the structure itself. This gas glows faintly in X-rays, invisible to our eyes but detectable by specialized telescopes. It is the connective tissue of the cosmic web, the substance that fills the space between galaxies, linking them together in ways both physical and gravitational. The filaments are not static. They are dynamic, evolving structures. Galaxies move along them like cars on a highway, their motions guided by the gravitational pull of the massive dark matter concentrations that define the filament's path. Some galaxies are falling into the filament from the surrounding voids, drawn by its gravitational attraction. Others are moving along the filament toward the massive galaxy clusters that form at the intersections where multiple filaments meet. It is a cosmic migration, a great flowing of matter following the invisible architecture laid down by dark matter in the early universe. Everything is in motion. Everything is falling. Everything is being drawn toward regions of higher density. Some filaments in the cosmic web are truly gargantuan. The Sloan. It is a cosmic filament that stretches across more than 1 billion light years of space. 1 billion light years. Think about that for a moment. Our entire Milky Way galaxy is about 100,000 light years across. The Sloan. Great Wall is 10,000 times longer than our galaxy is wide. It contains tens of thousands of galaxies, each with billions of stars, each star potentially hosting planets, each planet perhaps holding mysteries we cannot yet imagine. It is a structure so vast that it challenges our understanding of how the universe formed. But why should structures this large even exist? There is a limit to how large cosmic structures can grow, determined by the age of the universe and the speed at which gravity can pull matter together. The universe is only about 14 billion years old. That limits how much time gravity has had to assemble matter into large structures. And yet, structures like the Sloan Great Wall push right up against that theoretical limit. They are almost too large to exist, given the age of the cosmos. Their very presence tells us something profound about the early universe, about the initial conditions set in place mere moments after the Big Bang. Those tiny quantum fluctuations were arranged in just the right way to create these titans of structure. As you move along a filament, you notice something beautiful. The galaxies are not evenly distributed. They cluster together in some regions, creating brighter knots of light. In other regions, they spread out, and the filament appears dimmer. This variation gives the web its organic, natural appearance. It looks grown rather than constructed. It resembles the branching of tree roots seeking water, or the neurons in your brain reaching out to make connections, or the fungal networks beneath a forest floor linking tree to tree. The universe has created patterns at the largest scales that mirror patterns at the smallest scales. As above, so below. This repetition of structure across size scales suggests something fundamental about how nature organizes itself, from the quantum to the cosmic. The filaments also serve as cosmic highways for intergalactic gas. The space between galaxies is not a perfect vacuum, but rather filled with extremely diffuse hydrogen and helium, the primordial elements forged in the Big Bang. This gas flows along the filaments, channeled by gravity, eventually feeding into galaxies where it provides the raw material for new generations of stars. In this way, the cosmic web is not just a passive structure, but an active system, transporting matter from one region to another, enabling the ongoing process of star formation and galaxy evolution. The web is alive, in a sense. It breathes. It grows. It feeds the galaxies that define its shape. and those galaxies in turn influence its structure. It is a feedback loop on the grandest scale imaginable. Some filaments are denser than others, containing more galaxies and more dark matter. These thick, robust filaments act as the main thoroughfares of the cosmic web, the interstates connecting major metropolitan areas. Other filaments are thin and sparse, containing fewer galaxies, like back roads connecting small towns. But all of them, thick or thin, are part of the same interconnected network. There is no galaxy that is truly isolated, floating alone in the void. Every galaxy is connected, however distantly, to every other galaxy through this web of filaments. We are all linked, from the smallest dwarf galaxy to the largest elliptical giant. From one edge of the observable universe to the other, the cosmic web connects everything. Separation is an illusion. Connection is the truth. Now, let me share with you one of the most profound mysteries of modern astronomy. The cosmic web that you see, the glowing filaments of galaxies, represents only a tiny fraction of what is actually there. The galaxies are just the visible part of a much larger structure. Beneath and around and through the galaxies, there exists an invisible scaffolding made of something we call dark matter. It does not emit light. It does not absorb light. It does not interact with light at all. We cannot see it directly, and yet it is the most common form of matter in the universe. Dark matter outweighs normal matter by a factor of 5 to 1. For every atom of normal matter, there are 5 times more dark matter particles. And it is dark matter that built the cosmic web. How do we know dark matter exists if we cannot see it? We know through its gravitational influence on the things we can see. Galaxies rotate too fast. According to the laws of gravity and the amount of visible matter they contain, the outer stars should fly off into space. But they do not. Something invisible is holding them in place. Galaxy clusters contain hot gas that should evaporate into space, but it remains bound. Something invisible is confining it. When we look at distant galaxies, their light is sometimes bent and distorted by the gravity of intervening matter. But the visible matter alone is not enough to cause the distortion we observe. Something invisible is bending the light. That something is dark matter. Its presence is undeniable, even if we cannot perceive it directly. In the early universe, dark matter was the first to respond to gravity. While normal matter was still too hot and turbulent, still being pushed around by light and energy, dark matter was already beginning to clump together. It is immune to the pressures that affected normal matter in those early epochs. So dark matter pulled itself into elongated filaments and dense nodes, creating a gravitational framework. Then, over time, normal matter fell into this pre-existing structure, like water collecting in riverbeds carved by ancient glaciers. The galaxies formed where dark matter had already prepared a place for them. The cosmic web we see is really just the visible tip of a much larger dark matter web. The architecture was built by the invisible, and the visible simply followed. Scientists have created computer simulations of the universe that include dark matter and normal matter, along with the effects of gravity and cosmic expansion. They start these simulations with conditions matching the early universe, and then let physics run its course, watching billions of years of cosmic evolution unfold and fast forward. The results are stunning. These simulations produce cosmic webs that look remarkably similar to what we observe in the real universe. The filaments, the voids, the clusters, all emerge naturally from the mathematics. This gives us confidence that we understand the basic processes at work, even if we do not yet know what dark matter actually is. The simulations work. The theory matches observation. The universe makes sense, even if much of its substance remains mysterious. What is dark matter made of? We do not know. It is one of the greatest unsolved problems in physics. It could be exotic particles that have never been detected in our laboratories. It could be primordial black holes formed in the first moments after the Big Bang. It could be something entirely unexpected, something that will require new physics to understand. Scientists around the world are building ever more sensitive detectors, hoping to catch a dark matter particle interacting with normal matter. So far, dark matter remains elusive. It shapes the universe on the largest scales but refuses to reveal its nature. It is humble, lightened, silent, content to do its work unseen. Perhaps there is a lesson in that for us. The most important contributions are often the ones no one notices. The dark matter filaments are thicker and more massive than the visible galaxy filaments. If you could see dark matter, the cosmic web would appear much brighter and more prominent. The galaxies would be like lanterns hung on thick cables rather than the cables themselves. In some regions, dark matter halos surrounding individual galaxies overlap and merge, creating a nearly continuous distribution of dark matter along the filament. This creates a gravitational superhighway, a pathway where normal matter can flow easily, guided by the invisible hand of dark matter's gravity. Without dark matter, galaxies would be scattered randomly through space. There would be no web, no structure. Organization. Dark matter is the hidden order underlying the visible chaos. As we travel through this dark matter scaffolding, we pass through vast halos of invisible matter surrounding every galaxy. Our own Milky Way is embedded in a dark matter halo that extends far beyond the visible stars, possibly reaching out hundreds of thousands of light years. Right now, dark matter particles are passing through you. Billions of them every second, streaming through your body, through the earth, through everything, without interacting at all. They are ghosts moving through our world without touching it. Does that unsettle you, or does it fill you with wonder? You are immersed in an ocean of invisible matter, swimming through it, breathing it in a sense, and yet completely unaware of its presence except through the careful measurements of astronomers. The universe is far stranger than it appears. The ratio of dark matter to normal matter varies slightly from place to place in the cosmic web. In the densest regions, like the cores of massive galaxy clusters, normal matter becomes relatively more abundant because it can lose energy through radiation and sink deeper into gravitational wells. Dark matter cannot cool in this way, so it remains more spread out. In the voids, dark matter is extremely sparse, but it is still more common than normal matter. Even in the emptiest regions of space, dark matter is there, maintaining the large-scale structure. It never rests. It never ceases its work. Silent. Invisible. Essential. The universe would collapse into formless darkness without it, and yet we cannot touch it, see it, or even definitively identify it. Humility fills the heart when confronting such mysteries. Now, let us turn our attention to the spaces between the filaments, voids. If the filaments are the threads of the cosmic web, the voids are the spaces within each cell of the web. And they are vast, unimaginably vast. A typical void might measure 100 million light years across, though some are even larger. They are the emptiest places in the universe, regions where galaxies are almost completely absent. If you found yourself in the center of a cosmic void, you would see almost no galaxies in any direction. The nearest substantial concentration of galaxies might be 50 million light years away. You would be surrounded by darkness, broken only by the faintest wisps of intergalactic gas and the dim glow of a few lonely dwarf galaxies. It is a kind of emptiness most minds cannot fathom. The voids are not completely empty. Space is never truly empty. There is always something, even if that something is so sparse as to be effectively nothing. The voids contain thin clouds of hydrogen gas, perhaps 1 atom per cubic meter. To put that in perspective, the air you are breathing right now contains about 10 to the power of 25 molecules per cubic meter. The voids contain 1 atom per cubic meter. They are closer to a perfect vacuum than any laboratory on Earth has ever achieved. They contain faint wisps of dark matter, though even dark matter avoids these regions. They expand slightly faster than the rest of the universe because they have so little matter to slow the expansion. The voids are growing. Emptiness is winning. Why do the voids exist? They are a natural consequence of how structure forms in an expanding universe. Remember those tiny quantum fluctuations in the early universe? Some regions were slightly more dense than average, and those became the filaments and clusters. But other regions were slightly less dense than average. Matter fell toward the overdense regions. The underdense regions became even more empty. Matter evacuated the voids, flowing outward to join the surrounding filaments. Over billions of years, the voids became more empty and the filaments became more filled. It is a process of gravitational segregation, sorting matter into the cosmic web pattern we see today. The voids are not failures of structure formation. They are essential components of the web. Without voids, there could be no filaments. Some voids are truly colossal. The Botha's void, also known as the Great Void, is one of the largest known. It spans about 330 million light-years in diameter. Within this immense region, there are only about 60 galaxies compared to the 10,000 or more you would expect to find in a similar volume of space along a filament. Imagine the loneliness of being a civilization in one of those 60 galaxies. Your nearest galactic neighbor might be tens of millions of light years away. When you looked up at your night sky, you would see almost nothing. No Milky Way band. No nearby galaxies. Just a few faint smudges and otherwise pure darkness. It would be a very different view of the universe. And yet, even in their emptiness, the voids tell us something profound about the universe. Their very existence confirms our theories about how structure forms. The sizes of the voids are determined by the balance between gravity pulling matter together and the expansion of space pushing things apart. If the universe expanded faster, voids would be larger. If gravity were stronger, voids would be smaller. The voids we observe match the predictions of our cosmological models almost perfectly. They are evidence that we understand the fundamental forces shaping the cosmos. Empty space teaches us about the universe as surely as the galaxy-filled filaments do. Sometimes, what is not there is as informative as what is there. Silence speaks volumes if you know how to listen. As you cross from a filament into a void, the change is gradual but profound. Galaxy density decreases. The space between galaxies increases. Colors shift as you leave behind the regions of active star formation and heated gas. The cosmic web begins to thin and eventually disappears from view. You enter a region of almost perfect quiet. Here, the universe is closer to its primordial state, less modified by billions of years of structure formation. Time seems to move differently in the voids, or perhaps it is simply that less happens. Fewer stars are born. Fewer supernovae explode. Fewer black holes accrete matter. The voids are cosmic nature preserves, regions where the universe remains closer to its original simplicity. They are museums of the past, frozen in an earlier time. Some scientists believe that studying voids might help us understand dark energy, the mysterious force causing the accelerated expansion of the universe. The voids are expanding faster than average, pushed outward by the repulsive effect of dark energy, unopposed by the gravitational attraction of matter. By measuring the shapes and sizes of voids at different epochs in cosmic history, we can trace how dark energy has influenced cosmic evolution. The emptiest regions of space may hold the key to understanding the ultimate fate of everything. Will the universe expand forever, growing colder and more empty? Will dark energy eventually tear apart even atoms? The voids whisper hints about the far future, billions of years from now, when they may dominate the cosmos completely. There is a certain peace to be found in contemplating the voids. They remind us that the universe is not obligated to be filled. Most of space is empty, and that is perfectly natural. In our lives, we often feel we must fill every moment with activity, every silence with sound, every space with objects. But the cosmos teaches a different lesson. Emptiness has value. Voids give structure meaning. Without the empty spaces, the filaments would not stand out. Without silence, music would be noise. Without rest, activity loses its purpose. The cosmic voids are not failures or lacks. They are essential components of the grand design. They balance the web. They give it shape. Perhaps we too need our voids, our spaces of quiet emptiness, to give our lives structure and meaning. Where multiple filaments of the cosmic web intersect, something spectacular happens. Matter accumulates. Gravity intensifies. Galaxies crowd together in extraordinary numbers. These intersections are the nodes of the web, the great metropolitan centers of the universe. We call them galaxy clusters, and they are among the most massive structures bound by gravity. A single cluster can contain thousands of galaxies, all orbiting around their common center of mass. The total mass can exceed 1,000,000,000 times the mass of our Sun. That is a 1 followed by 15 zeros. That is more mass than in 100,000 galaxies like our Milky Way. It is almost incomprehensible. And yet, dozens of these titans exist within the observable universe, marking the places where cosmic filaments meet. The largest galaxy clusters are relatively rare. Most nodes in the cosmic web are smaller, containing only dozens or hundreds of galaxies rather than thousands. These smaller groupings are called groups or pore clusters. Our own Milky Way resides in such a group, known as the local group, along with Andromeda and about 50 smaller galaxies. But even our modest neighborhood is a node in the web, a place where local filaments intersect. We are connected to the larger structure. From our position in the local group, we can trace connections to the Virgo cluster, and from there to the Laniakea Supercluster, and onward into the greater web. We are part of something vast. You are part of something vast. At the heart of a massive galaxy cluster, conditions are extreme. Thousands of galaxies swarm in a relatively small volume of space. They move at velocities of hundreds or even thousands of kilometers per second, held in place by the immense gravity of the cluster. Occasionally, galaxies collide and merge, though space is so vast that even in a crowded cluster, such events are relatively rare. Between the galaxies, the space is filled with hot gas, heated to tens of millions of degrees by the gravitational energy of the cluster. This gas glows brightly in X-rays, often containing more normal matter than all the galaxies combined. And surrounding everything, providing the gravitational glue that holds it all together, is an enormous halo of dark matter extending far beyond the visible cluster. One of the most famous galaxy clusters is the Coma cluster, located about 320 million light-years from Earth in the constellation Coma Berenices. It contains over 1,000 identified galaxies and probably many more that are too faint to detect. The cluster is still growing, accreting new galaxies from the surrounding filaments. It is a cosmic city that never stops expanding. When we observe the Coma cluster, we are looking back in time, seeing it as it was 320 million years ago when the light now reaching our telescopes began its journey. That time, dinosaurs walked the Earth. Life on our planet was very different. But the Coma cluster endures, slowly evolving on its own immense timescale, indifferent to the brief flash of biological evolution occurring on a small planet orbiting an ordinary star. The formation of a galaxy cluster is a violent process that unfolds over billions of years. Smaller groups of galaxies fall together along filaments drawn by gravity. As they approach, their velocities increase, accelerated by the gravitational pull of the growing cluster. Eventually, these groups collide, but this is not a collision like you might imagine. The galaxies within each group generally pass through each other without individual galaxies actually touching. Remember, galaxies are mostly empty space. But the hot gas within each group does collide, creating shock waves and heating the gas to even higher temperatures. The result is a merged cluster, larger and more massive than either progenitor. This process has been repeated countless times throughout cosmic history, building the massive clusters we observe today from smaller building blocks. Some of the most massive galaxy clusters are the result of recent major mergers. The Bullet cluster is a famous example. It consists of two galaxy clusters that have recently passed through each other. When we observe it, we can see clear separation between the galaxies, which passed through largely unaffected, and the hot gas, which was slowed by the collision and now lags behind. This separation has provided some of the best evidence for dark matter. By mapping the gravitational lensing effect, which reveals where the mass actually is, astronomers found that most of the mass traveled with the galaxies, not with the gas. This invisible mass moving with the galaxies must be dark matter. The Bullet cluster gave us a window into the invisible universe, proving that dark matter is real and distinct from normal matter. Galaxy clusters are the largest objects in the universe that are held together by their own gravity. Nothing larger is gravitationally bound. Superclusters, which contain multiple galaxy clusters, are not bound structures. They are simply regions of the cosmic web where multiple nodes happen to be close together. Cosmic expansion will eventually pull superclusters apart, but individual clusters will remain intact, held together by their immense gravity. In a sense, galaxy clusters represent the upper limit of structure in the universe. They are cosmic islands that will endure even as the space between them expands and the web itself stretches and fades. Trillions of years from now, when the universe is far older and more dilute, galaxy clusters will be isolated beacons in an expanding ocean of darkness, the last bastions of density in a universe approaching maximum entropy. When you contemplate a galaxy cluster, you are witnessing gravity's ultimate achievement. Here, the fundamental force that shapes the cosmos has gathered matter from across hundreds of millions of light years and concentrated it into a region small enough that light can cross it in mere millions of years. Here, thousands of galaxies dance together in a gravitational ballet that will continue for eons. Here, the cosmic web reveals its deepest nodes, the places where all threads connect. Standing before a galaxy cluster, even if only an image is captured by telescopes, should inspire awe. It is a monument to the organizing power of nature. It is proof that the universe, despite its vastness and age, can create structures of staggering complexity and beauty. It is a reminder that you, too, are the product of organization, of structure, of the same forces that built these cosmic titans. Let us now pull back our perspective and look at an even larger scale. We have explored individual filaments, voids, and nodes. Now, let us see how these elements combine into something grander. We live within a vast collection of galaxy clusters, groups, and filaments called the Laniakea Supercluster. The name Laniakea means immeasurable heaven in Hawaiian, and it is an appropriate name. This structure spans 520 million light-years across and contains the mass of 100,000 trillion suns. It encompasses our local group, the Virgo cluster, and about 100,000 other galaxies, all bound together not by gravity, but by their common motion through space. Laniakea is our cosmic neighborhood, and until recently, we did not even know we lived in it. The Laniakea Supercluster was defined in 2014 by a team of astronomers who mapped the motions of galaxies in our cosmic neighborhood. They discovered that all the galaxies in a particular region are flowing toward a common gravitational center, like rivers flowing toward the sea. This motion defines a basin of attraction, a region of space where all matter is moving in the same general direction. That basin is Laniakea. At its heart lies the Great Attractor, a gravitational anomaly that has been pulling our local group and countless other galaxies toward it for billions of years. We are falling toward the Great Attractor at a velocity of about 600 kilometers per second, though we will not arrive for many billions of years, if ever, because cosmic expansion is also at work, pushing us apart. The Great Attractor itself is partially hidden from our view. It lies behind the plane of the Milky Way, in a direction where dust and stars in our own galaxy block our view of the deeper universe. This region is called the Zone of Avoidance, and it has frustrated astronomers for decades. We know something massive is there, pulling on us, but we cannot see it clearly. Observations at wavelengths that penetrate dust, such as infrared and radio, have revealed that the Great Attractor region contains several massive galaxy clusters, most notably the Norma cluster. These clusters, combined with even more distant structures beyond them, create the gravitational pull we detect. But the full picture remains obscured, hidden behind the veil of our own galaxy. Some mysteries remain just out of sight. Laniakea is not the only supercluster in the universe. It is one of millions, each containing tens of thousands to hundreds of thousands of galaxies. Our neighboring superclusters include Coma, Hydra, and Centaurus, among others. The boundaries between superclusters are not sharp walls, but rather gradual transitions where the flow of galaxies changes from one basin of attraction to another. In the spaces between superclusters lie some of the largest voids, vast empty regions that separate these immense concentrations of matter. The universe on the largest scales resembles foam, with superclusters forming the thin walls and edges where bubbles meet, and voids forming the interior volumes of the bubbles. It is an elegant geometry, simultaneously complex and simple, chaotic and ordered. What determines the size and shape of superclusters? Once again, it comes down to the initial conditions set in the very early universe. The pattern of quantum fluctuations from the first moments after the Big Bang determined where matter would be slightly more dense and where it would be slightly less dense. These fluctuations had a characteristic size scale imprinted by the physics of the early universe. That size scale corresponds roughly to the size of superclusters today. In a sense, the structures we see now are simply those primordial ripples grown large through billions of years of gravitational amplification. The seeds were planted at the beginning, and now we harvest the fruits. The universe was born with a plan, written in quantum foam and gravity, and it has been following that plan ever since. Living within Laniakea affects us in subtle ways. The gravitational pull of the Great Attractor and other massive structures creates a peculiar velocity, a motion that is superimposed on the general expansion of the universe. When we measure the cosmic microwave background radiation, the afterglow of the Big Bang, we observe a dipole pattern. One side of the sky appears slightly hotter, the other slightly cooler. This is not because the background radiation itself varies, but because we are moving through it. Our motion toward the Great Attractor causes the radiation ahead of us to be blue-shifted, appearing hotter, while the radiation behind us is red-shifted, appearing cooler. This simple observation tells us we are not at rest in the cosmos. We are falling. We have always been falling. and that is perfectly natural. The motion within Laniakea is not the end of the story. The entire Laniakea Supercluster is itself moving, pulled by even larger structures beyond. There is some evidence for an enormous concentration of mass called the Shapley attractor lying beyond Laniakea, which may be influencing the motion of multiple superclusters in our region of the universe. This suggests structure on scales even larger than superclusters, although at such scales the definition of structure becomes ambiguous. Are these genuine bound structures or simply statistical fluctuations in galaxy density? The answer is not entirely clear. What is clear is that the cosmic web extends as far as we can observe, and perhaps beyond. There may be no end to the hierarchy of structure, only a limit to our ability to observe it. Understanding our place within Laniakea gives us a new sense of cosmic address. We live on Earth, which orbits the Sun, which resides in the Orion arm of the Milky Way galaxy, which is part of the local group, which lies on the outskirts of the Virgo cluster, which is part of the Laniakea Supercluster, which is connected to the greater cosmic web extending across the observable universe. Each level of this address places us in a larger context, connecting us to structures of ever-increasing scale. You are not just a person in a place. You are a node in a network that spans the cosmos. Your existence is woven into the very fabric of universal structure. When you look up at the night sky, you are not looking outward from Earth. You are looking around within the cosmic web, seeing other nodes, other filaments, other structures that share your cosmic neighborhood. You are home. You are home. You have always been home. How do we know all of this? How have astronomers mapped the cosmic web across billions of light years? The answer lies in one of the most ambitious scientific projects ever undertaken, the Sloan Digital Sky Survey. Beginning in the year 2000, the Sloan telescope in New Mexico began systematically observing and measuring the distances to millions of galaxies. Over the course of 2 decades, it has created the most detailed three-dimensional map of the universe ever made, revealing the cosmic web in unprecedented detail. Without the Sloan survey and others like it, we would still be guessing about large-scale structure. These projects have transformed cosmology from a field based on philosophy and speculation into a precision science based on data. The universe is no longer a mystery. It is a known landscape. The process of mapping the cosmic web is methodical and painstaking. First, the telescope takes images of a region of the sky, identifying millions of galaxies. Then, for a subset of these galaxies, it measures a spectrum, spreading the light into its component colors like a prism. Within that spectrum are absorption and emission lines at specific wavelengths characteristic of particular elements. But these lines are shifted toward the red end of the spectrum because the universe is expanding. The more distant the galaxy, the faster it is receding from us, and the greater the redshift of its spectral lines. By measuring the redshift, astronomers can calculate the distance to the galaxy. Plot millions of galaxies with known positions and distances, and the three-dimensional structure of the universe emerges. The cosmic web becomes visible. One of the most iconic images from the Sloan survey is the galaxy wedge diagram. Imagine slicing through the cosmic web with a thin wedge, like cutting a slice of pie, extending from Earth out to distances of billions of light years. When you plot the galaxies in this slice, a pattern leaps out at you. The galaxies are not randomly scattered. They form filaments pointing toward you and away from you, separated by voids. The pattern is unmistakable. This single image convinced the scientific community that large-scale structure is real and ubiquitous. It is often called the cosmic web diagram, and for good reason. It looks like a web. There is no other way to describe it. Nature has created a pattern at the largest scales that mirrors patterns at small scales, from spiderwebs to neural networks. The Sloan survey has measured redshifts for over 3 million galaxies and has imaged hundreds of millions more. This massive dataset has enabled countless scientific discoveries beyond just mapping structure. It has been used to measure the expansion rate of the universe, to constrain the properties of dark energy, to study galaxy evolution, to find rare objects like quasars and supermassive black holes, and to test fundamental theories of cosmology. The data is publicly available, allowing scientists around the world to explore it and make new discoveries. It is a gift to humanity, a treasure trove of information about the cosmos. And the work continues. New surveys like the Dark Energy Spectroscopic Instrument are pushing even further, measuring even more galaxies at even greater distances, extending the map of the cosmic web. Creating these surveys requires extraordinary technology and teamwork. The telescope itself is a marvel of engineering, using digital imaging sensors far more sensitive than the human eye. The data processing requires supercomputers to analyze terabytes of information. Teams of scientists from around the world collaborate to design the survey, operate the telescope, process the data, and interpret the results. It is a collective effort, bringing together experts in optics, electronics, software, astronomy, physics, and statistics. No single person could do this alone. The cosmic web was revealed by a web of human cooperation, a network of minds working together toward a common goal. Perhaps that is fitting. Structure creates structure. Connection reveals connection. The impact of these surveys extends beyond professional astronomy. The data and images have captured public imagination, appearing in documentaries, books, museums, and classrooms. They have changed how people think about the universe. Before these maps existed, the cosmos seemed vast and unknowable. Quote, "Now we have a map. The unknown has become known. The mysterious has become familiar. We can point to our location on a map of the universe, just as we can point to our location on a map of Earth. This is psychologically profound. It transforms the universe from an abstraction into a place. It makes the cosmos feel less alien and more like home. You are not lost in an infinite void. You are located in a specific place within a mapped structure. You have cosmic coordinates. Future surveys will map even more of the universe in even greater detail. The Vera Rubin Observatory, expected to begin operations soon, will survey the entire visible sky every few nights, creating time-lapse movies of the cosmos. It will discover millions of new galaxies, track transient events like supernovae, and map the dark matter distribution through gravitational lensing. The Nancy Grace Roman Space Telescope will survey vast areas from space, free from atmospheric distortions. The European Space Agency's Euclid mission will map billions of galaxies across cosmic time. Each of these projects will add new layers of information to our map of the cosmic web. The chart will become more detailed. The structure will be revealed in higher resolution. And with each new discovery, our understanding will deepen. We are living through the golden age of cosmic cartography. What will we learn from these future observations? Will we find structures even larger than what we know today? Will we discover new patterns in the cosmic web that challenge our theories? Will we finally understand the true nature of dark matter and dark energy? These questions remain open. The universe still holds secrets. But with each new observation, with each new galaxy measured, we move closer to a complete understanding. The cosmic web that once seemed impossibly complex is becoming comprehensible. Its patterns are emerging from the data like a signal rising above noise. We are learning to read the architecture of the universe. And in learning to read it, we are learning to understand our place within it. The map is not just a scientific tool. It is a mirror showing us where we belong in the grand scheme of existence. The cosmic web we see today is not how it has always been, nor is it how it will always be. It grows. It changes over billions of years, shaped by the competing forces of gravity trying to pull matter together and cosmic expansion trying to push things apart. In the early universe, shortly after the Big Bang, the web was only beginning to form. Matter was distributed almost uniformly, with only tiny fluctuations in density. But those fluctuations were enough. Gravity amplified them, slowly at first, then faster as regions of higher density attracted more matter and became even denser. Over time, the filaments emerged from the fog, stretching and thinning as the universe expanded, slowly taking on the structure we recognize today. When the universe was young, only a few 100 million years old, the first stars were just beginning to form. At this time, the cosmic web was present but much more subtle. The filaments were thinner, the voids less empty, the contrast between dense and sparse regions less pronounced. Galaxies as we know them did not yet exist. Instead, there were small clumps of dark matter within which the first stars ignited, burning bright and brief. These early stars lived fast and died young, exploding as supernovae and enriching the universe with elements heavier than hydrogen and helium. Gradually, these small clumps merged into larger structures. The cosmic web was being woven thread by thread, star by star, galaxy by galaxy. Creation was a process, not an event. As billions of years passed, the cosmic web became more pronounced. Filaments grew thicker as matter accumulated along them. Voids became more empty as matter flowed out of them toward the filaments. Galaxy clusters formed where filaments intersected, growing through mergers and accretion. The universe was organizing itself, sorting matter into an increasingly hierarchical structure. Small clumps merged to form larger clumps. Galaxies fell together to form groups. Groups fell together to form clusters, and clusters connected along filaments spanning ever greater distances. By the time the universe was half its current age, about 7 billion years after the Big Bang, the cosmic web was recognizable, though still evolving. It looked more or less like it does today, but the details were different. Work was ongoing. Today, we live in a special time in cosmic history. The cosmic web is at its peak. Structure has had time to develop, but has not yet been torn apart by cosmic expansion. Dark energy, the mysterious force causing the acceleration of the universe, has been the dominant component of cosmic energy for only a few billion years. Before that, matter dominated, and gravity was winning the battle, pulling structures together. Now, dark energy is winning, pushing structures apart. But the transition happened relatively recently on cosmic timescales. Right now, in this epoch, the universe displays its structure most prominently. We are fortunate to exist at a time when the cosmic web can be observed and studied. In the far future, it will be much harder to see. What does the future hold for the cosmic web? As dark energy continues to drive accelerated expansion, the filaments will stretch and thin. The voids will grow larger. The distance between galaxy clusters will increase. Eventually, billions of years from now, clusters that are currently neighbors will recede from each other so rapidly that light from one will no longer reach the other. Cosmic expansion will have carried them beyond each other's cosmic horizons. They will become causally disconnected, unable to influence each other in any way. The cosmic web will fragment. Each cluster will become an island universe, isolated and alone. And within each cluster, galaxies will merge as they continue to orbit their common center. Eventually, each cluster will coalesce into a single enormous elliptical galaxy, the tombstone of a once vibrant structure. In this far future, trillions upon trillions of years from now, the universe will be a very different place. The stars will have exhausted their fuel. Star formation will have ceased because all the gas will have been used up or dispersed. The universe will be populated by remnants, stellar corpses like white dwarfs, neutron stars, and black holes. Even these will eventually decay through quantum processes, though this takes unimaginable spans of time. The universe will approach a state of maximum entropy, a heat death where everything is at the same temperature and no energy. Gradients exist to power any processes. The cosmic web, that magnificent structure we have been exploring, will be long gone, dissolved into the expanding void. But that is so far in the future that it is almost meaningless. Enjoy the present. Savor the structure. We live in the golden age, but let us not dwell on endings. Let us return to the present, to the cosmic web as it exists now in all its glory. Let us appreciate that we exist at a time when the universe is structured, when galaxies cluster along filaments, when voids punctuate the darkness, when the grand architecture can be observed and studied. This is a gift, a chance to witness one of the most beautiful patterns nature has ever created. Billions of years of cosmic evolution, trillions of galaxies, quadrillions of stars, all organized into a web that spans the observable universe. And you, reading these words or listening to this narration, are part of it. Your atoms were forged in stars that existed within this web. Your consciousness emerged from matter organized by these same forces. You are the cosmos reflecting on itself. The evolution of the cosmic web teaches us about impermanence. Nothing lasts forever, not even structures that span billions of light years. Changes. Everything evolves. And yet, there is beauty in this impermanence. The fact that the cosmic web will someday dissolve makes it more precious, not less. The fact that we exist at just the right time to observe it makes our existence more meaningful, not less. Perhaps the lesson is this: appreciate what exists now. Marvel at the present structure. Do not mourn the future dissolution or regret the past simplicity. The cosmic web is here, now, in this epoch, and so are you. That coincidence is not random. It is the result of 14 billion years of cosmic evolution creating the conditions necessary for complexity, for structure, for consciousness. You are where you are supposed to be when you are supposed to be there. This is your time. Throughout this journey, we have returned again and again to a single observation. The cosmic web looks organic. It looks grown rather than assembled. It resembles neural networks, fungal networks, root systems, river deltas, and countless other patterns we find in nature. This is not coincidence. This is not our minds imposing patterns where none exist. The similarity is real and profound. It suggests that the same mathematical principles govern structure formation at all scales, from microscopic to cosmic. Whether we are talking about neurons connecting in a brain or galaxies connecting along filaments, the underlying process is similar. Networks form when nodes connect through pathways that minimize energy or maximize efficiency. Nature finds the same solutions to similar problems regardless of scale. Why does nature create networks? Because networks are efficient. They connect many locations using the minimum amount of material or energy. A tree does not grow a root to every grain of soil individually. It grows a branching network of roots that explores the soil efficiently. Your brain does not connect every neuron to every other neuron. It grows specific connections that enable complex behavior while minimizing metabolic cost. And the universe does not distribute galaxies uniformly through space. It organizes them along filaments that minimize gravitational potential energy while maintaining connectivity. Networks solve optimization problems. They are nature's way of doing more with less. And when you optimize under similar constraints, you get similar structures, regardless of whether you are building a brain or a cosmos. The mathematical field studying networks is called graph theory. It provides tools to analyze any system consisting of nodes and connections. The cosmic web is a graph where galaxies are nodes and gravitational or filamentary associations are connections. A social network is a graph where people are nodes and friendships are connections. The internet is a graph where devices are nodes and communication links are connections. These graphs have common properties. They often show small world characteristics where any two nodes are connected through relatively few intermediate nodes. They show clustering where nodes tend to form tight-knit communities. They show hubs where certain nodes have far more connections than average. These properties emerge naturally in many different contexts. The cosmic web is not unique in its structure. It is part of a universal class of network architectures. One of the most fascinating aspects of networks is their robustness and fragility. Networks are typically robust against random failures. If you randomly remove a few nodes, the network usually remains connected, with information or material still able to flow from any node to any other. But networks are fragile against targeted attacks. If you remove the most connected hubs, the network can fragment into isolated pieces that can no longer communicate. The cosmic web shows the same behavior. It is robust against the random collapse or disappearance of individual galaxies. The web remains connected. But if you could somehow remove the largest galaxy clusters, the nodes where many filaments meet, the web would fragment. The universe would become disconnected. This is not just an abstract mathematical property. It has implications for how information and matter flow through the cosmos. The organic appearance of the cosmic web raises a provocative question. Is the universe alive? Not in the biological sense, of course. Galaxies do not reproduce or metabolize. But perhaps in a broader sense, the universe exhibits properties we associate with living systems. It is organized. It evolves. It responds to its environment. It processes information through the interactions of the parts. Some philosophers and scientists have explored this idea, suggesting that the universe might be better understood using concepts from biology and information theory rather than just physics. This is highly speculative, and many scientists would disagree. But it is worth pondering. When you look at the cosmic web and see something that resembles a living network, perhaps your intuition is sensing something real. Perhaps organization and structure are more fundamental than we realize. Whether or not the universe is alive, it is certainly creative. It creates complexity from simplicity. It creates structure from near uniformity. It creates galaxies from clouds of gas, stars from collapsing cores, planets from dust, and potentially life and consciousness from organic chemistry. Each step involves organization increasing, entropy locally decreasing, even as it increases globally. The cosmic web is part of this creative process. It is the scaffolding upon which everything else is built. Without the web, matter would be too diffuse to form galaxies. Without galaxies, stars would not form. Without stars, heavy elements would not exist. Without heavy elements, planets and life as we know it would be impossible. The cosmic web enabled your existence. You are here because the universe is organized. Disorder could not create you. The organic nature of the cosmic web also offers aesthetic pleasure. It is beautiful, not in a human-designed way, but in the way natural things are beautiful. It has the elegance of simplicity combined with the richness of complexity. It has symmetry without being repetitive. It has order without being rigid. When scientists first saw maps of the cosmic web, many described their reaction as aesthetic awe, a sense of witnessing something profound and beautiful. Art and science meet in the cosmic web. It is simultaneously a physical structure described by equations and a visual masterpiece that stirs emotions. Perhaps this is what truth looks like. Perhaps beauty and truth are not separate but deeply connected. Perhaps the universe is beautiful because it is true, and true because it is beautiful. As we conclude this segment, let us reflect on what it means that the universe is organic in appearance and perhaps in nature. It means the cosmos is not cold and mechanical, not a clockwork device ticking away without meaning. It is something richer, something that grows and changes and creates. It is a system that has produced you, a conscious being capable of understanding it. In a real sense, the universe is looking at itself through your eyes right now as you contemplate the cosmic web. You are the method by which the cosmos has become self-aware in this local region of space and time. That makes you part of something vast and beautiful and ongoing. The cosmic web is not just out there, separate from you. You are in it, of it, made by it, and aware of it. Subject and object merge. Observer and observed are one. We have traveled far together, across billions of light years and billions of years of time. We have explored filaments and voids, dark matter scaffolding and galaxy clusters. We have contemplated the evolution and organic nature of the cosmic web. Now, as our journey draws to a close, let us bring the focus back to where we started, back to us. Back to you. Where do we fit into this vast structure? What does it mean to be a small cluster of atoms on a small planet, aware of the immense web that surrounds us? These are not just scientific questions. They are personal questions, existential questions. And the answers matter because they shape how we see ourselves and our place in the cosmos. When you first learn about the cosmic web, a common reaction is to feel insignificant. How can your life matter when you are just one person on one planet, orbiting one star in one galaxy among billions, all part of a structure so vast that human timescales are irrelevant? This feeling is understandable but incomplete. Yes, you are small. That is objectively true. But smallness and significance are not opposites. You are not separate from the cosmic web. You are made of its substance. The atoms in your body were forged in stars that existed somewhere along these filaments. You are not looking at the cosmic web from outside. You are participating in it from within. Your existence is evidence that the universe can organize matter into something capable of thought and feeling and wonder. That is not insignificant. Consider this perspective. The universe is not just matter and energy arranged in space and time. It is also a process, a cosmic evolution from simple to complex, from uniform to structured. You are an advanced stage in that evolution. The universe was once just hydrogen and helium. Then it created carbon and oxygen and iron through nuclear fusion in stars. Then it assembled those elements into molecules, into planets, into living cells, into brains capable of understanding their own origins. That is an extraordinary trajectory, and you are part of it. When you study the cosmic web, you are not an external observer analyzing a specimen. You are the universe examining itself, a node in the web that has become conscious and curious. Your significance comes not from your size, but from your role. There is also a deep emotional resonance in understanding our connection to the cosmic web. You are not alone. Not just in the trivial sense that other humans exist, but in the profound sense that everything is connected. The stars you see in the night sky are part of the same galactic filament that includes our Milky Way. The light from distant galaxies has traveled for billions of years to reach your eyes, connecting you to regions of the universe impossibly far away. Even the atoms in your left hand and your right hand were likely formed in different stars, possibly in different galaxies, yet now they are together in you. You are a meeting place, a convergence point where matter from throughout the cosmic web has gathered. Embody connection. You are connection made conscious. Understanding your place in the cosmic web can also provide perspective on daily concerns. The anxieties and stresses that occupy your mind, while real and valid in your subjective experience, are part of a much larger context. You are a being in a universe billions of years old and billions of light years across. Your problems, your joys, your entire life exist within this vast frame. This is not to diminish your experiences. It is to expand them. When you feel overwhelmed, you can remember that you are part of something enduring and magnificent. When you feel lost, you can remember that you exist within a structure, a web that connects everything. The universe is not chaos. It is organized. And you are part of that organization. You have cosmic coordinates. You belong. Your awareness of the cosmic web is itself remarkable. For most of human history, this structure was invisible. People looked at the night sky and saw stars, not knowing they were distant suns and distant galaxies organized into vast filaments. Only in the last few decades have we mapped the web and understood its nature. You live in an extraordinary time, a time when the universe has revealed its architecture. Previous generations never knew this. Future generations may take it for granted. But you are living through the discovery. You are among the first humans to see the cosmic web and understand your place within it. That makes this moment special. This knowledge is new. It is precious. And you have access to it. What will you do with this understanding? Will it change you? There is also responsibility in this knowledge. You now know that the universe is structured and beautiful and vast beyond comprehension. You know that you are part of it, connected to everything through chains of causation stretching back to the Big Bang. What does this knowledge require of you? Perhaps it requires gratitude, appreciation for the improbable sequence of events that led to your existence. Perhaps it requires humility, acknowledging your smallness even as you celebrate your significance. Perhaps it requires action, a commitment to preserving the small pocket of complexity and consciousness that has emerged on this planet. Or perhaps it simply requires presence, a willingness to be here now, aware of the cosmic context of your existence. These are choices only you can make. The cosmic web makes no demands, but understanding it changes the possibilities. Finally, your place in the cosmic web is still being written. You are not a fixed point, but a node still forming connections, still evolving, still contributing to the pattern. Every action you take, every thought you think, every connection you make with another person is part of the ongoing story of cosmic organization. The universe creates structure at all scales, and you are part of that creative process. You are not a passive observer of the cosmic web. You are an active participant. In your own small way, through the connections you form and the meaning you create, you are weaving your own web, your own network of relationships and influences. And that personal web is nested within the social web of humanity, which is nested within the biosphere of Earth, which is nested within the cosmic web. Scales within scales, patterns within patterns. And you are part of all of it. As we approach the end of our journey, it is important to acknowledge what we do not know. For all the marvels we have discovered about the cosmic web, mysteries remain. Deep mysteries that challenge our understanding and remind us that the universe is stranger than we imagine, and perhaps stranger than we can imagine. Science has revealed the structure of the cosmos, but it has also revealed the depths of our ignorance. The more we learn, the more we realize how much remains unknown. This is not a failure of science. It is its great strength. Science is comfortable with uncertainty. It welcomes mystery. It seeks truth without claiming to have reached final answers. And the cosmic web holds many secrets still. What lies beyond the observable universe? Our maps of the cosmic web extend to the edge of what we can see, limited by the finite speed of light and the finite age of the universe. There are regions of space so distant that their light has not had time to reach us. What is out there? Does the cosmic web continue indefinitely, stretching through infinite space? Or does the universe have an edge, a boundary beyond which nothing exists? Or perhaps the universe wraps around on itself in ways we cannot visualize, finite but without boundary. These questions touch on the deepest problems in cosmology. We do not know the answer. We may never know. The cosmic web we observe is just the part we can see. The totality may be infinitely larger, or it may be all there is. Either answer is dizzying. What is the true nature of dark matter? We know it exists through its gravitational effects. We know it outweighs normal matter. We know it built the cosmic web. But we do not know what it is made of. Decades of experiments have failed to detect dark matter particles directly. Is it made of weakly interacting massive particles, as many theories suggest? Is it made of axions, hypothetical particles that barely interact with anything? Is it primordial black holes? Or is it something entirely unexpected, something that will require new physics to understand? Until we detect it directly, dark matter remains a mystery. The scaffolding of the cosmic web is invisible not just to our eyes, but to our instruments. We see its effects, but not its essence. What is dark energy? It is even more mysterious than dark matter. Dark energy makes up about 68% of the total energy of the universe. It causes the accelerated expansion that will eventually dissolve the cosmic web, but we have no idea what it actually is. Is it a property of space itself? A cosmological constant, as Einstein once proposed? Is it a dynamic field that changes over time? Is it a sign that our theory of gravity needs modification at cosmic scales? These are open questions. The fate of the universe depends on dark energy, yet we understand almost nothing about it. It is humbling to realize that most of the universe is made of things we cannot identify. Normal matter, the stuff we are made of, is a small minority component. We are the exception, not the rule. Are there other cosmic webs in other universes? Some theories suggest that our universe is just one among many, part of a vast multiverse where different regions have different physical laws. If this is true, each universe might have its own cosmic web with different properties. Some might have stronger gravity, leading to more compact structures. Others might have weaker gravity, leading to more diffuse structures. Some might have no structure at all, remaining uniform and lifeless. We might exist in a universe that is fine-tuned for complexity and life. Or we might simply be lucky, existing in the one universe among countless trillions where conditions happen to allow for stars and planets and consciousness. This is deeply speculative, but it reminds us that even our cosmic web might be just one example among infinite possibilities. Is there life elsewhere in the cosmic web? This is perhaps the most compelling mystery. We know that planets are common. Most stars have planets. Many planets are in the habitable zone where liquid water can exist. The raw materials for life, carbon and oxygen and nitrogen, are abundant throughout the cosmic web. If life arose on Earth, why not elsewhere? Are there other beings on other worlds looking up at their skies and pondering the same questions? Are there civilizations far more advanced than ours, perhaps capable of traveling between stars or even between galaxies? Or is life extraordinarily rare, with Earth being a unique oasis in a vast cosmic desert? We do not know. The cosmic web may be teeming with life and consciousness, or we may be profoundly alone. Both possibilities are awe-inspiring. Why does the universe exist at all? This is the ultimate question, the one that science alone cannot answer because it touches on the boundary between physics and philosophy. Why is there something rather than nothing? Why does the universe have the particular laws and constants that it does? Why are we here to ask these questions? Some find answers in religion or philosophy. Others are content to say the universe simply is, without deeper explanation. Still others hope that a future theory of everything will provide answers. But for now, existence itself remains the deepest mystery. The cosmic web is magnificent and intricate and beautiful. But why does it exist? That question echoes through the voids and along the filaments, unanswered and perhaps unanswerable. And yet, the asking itself is meaningful. These mysteries are not reasons for despair. They are reasons for wonder. They are invitations to continue exploring, to keep asking questions, to remain curious. The cosmic web has revealed its structure to us, but it has not revealed all its secrets. There is work yet to be done, discoveries yet to be made, understanding yet to be achieved. And perhaps some mysteries will remain forever beyond our grasp, reminding us that the universe is greater than our comprehension. There is humility in accepting what we do not know. There is courage in continuing to seek answers despite uncertainty. The cosmic web teaches us both. It shows us what is knowable and hints at what remains mysterious. Both the knowledge and the mystery are gifts. Both deserve our gratitude and our awe. We have reached the end of our journey together, but the cosmic web endures. Long after these words have been spoken and forgotten, the filaments will continue their slow evolution. Galaxies will continue their orbits. Dark matter will continue shaping structure. The voids will continue expanding. The universe does not need our observation to exist. It was here long before we arrived and will be here long after we are gone. And yet, there is something profound in the fact that for this brief moment in cosmic time, a small part of the universe has become aware of the whole. You have become aware of the cosmic web. That awareness is itself a cosmic event, as significant in its way as the formation of stars or galaxies. Throughout this hour, we have explored the largest structure in existence. We have traveled along filaments of galaxies, crossed vast voids of emptiness, and visited the massive nodes where cosmic threads converge. We have contemplated dark matter and dark energy, the invisible forces that shape everything we see. We have reflected on evolution and impermanence, on connection and significance, on knowledge and mystery. We have asked what it means to be part of something so vast and beautiful. These are not just astronomical questions. They are human questions. They are your questions. The cosmic web is not just a scientific subject. It is a mirror in which we see ourselves and our place in the universe reflected back. What will you take from this journey? Perhaps a sense of perspective, an understanding that your daily concerns exist within a much larger context. Perhaps a feeling of connection, a recognition that you are part of an interconnected whole stretching across billions of light years. Perhaps a sense of wonder, an appreciation for the beauty and complexity that nature creates. Or perhaps simply a moment of peace, a brief respite from the noise and demands of daily life, a chance to contemplate something vast and eternal. Whatever you take from this, know that it is yours. The cosmic web has given you something. What you do with that gift is your choice. The cosmic web reminds us that structure and beauty emerge naturally from simple rules applied over vast spans of time. Gravity and expansion, matter and energy, these basic ingredients combined to create the most magnificent architecture in existence. No designer was needed. No blueprint was followed. The universe organized itself. This is not a cold or meaningless process. It is a creative one. The universe makes galaxies and stars and planets and, on at least one planet, living beings capable of understanding it all. That creativity is ongoing. Even now, new structures are forming. New stars are being born in nebulae along the filaments. New planets are cooling and becoming habitable. The cosmic web is not a static monument. It is a living, evolving system. Creation continues. Let me leave you with one final thought. The cosmic web is the largest structure, yes, but it is not the only structure. Structure exists at every scale in the universe. Quarks form protons. Protons form atoms. Atoms form molecules. Molecules form cells. Cells form organisms. Organisms form ecosystems. Ecosystems form the biosphere. The biosphere exists on a planet. Planets orbit stars. Stars cluster in galaxies. Galaxies connect along filaments. Each level of structure enables the levels above it. Each level contains multitudes of the levels below it. You exist at one level in this hierarchy, but you are connected to all levels. You are made of quarks and you are part of the cosmic web. You span scales. You span scales. You embody the universe's tendency toward organization. When you go outside tonight and look up at the sky, remember what you now know. The stars are not scattered randomly. They are part of a structure. Our Milky Way is a galaxy in a filament in the cosmic web. You are looking at the web from within. Every photon of starlight that enters your eye has traveled along the threads of this structure. You are receiving messages from the web, information about its composition and organization. And in receiving those messages, in processing that information through your neurons and your consciousness, you are participating in the web's activity. You are a node that has become aware. You are the universe studying itself. The cosmic web exists in space, but it also exists in your understanding. It is both out there and in here. The cosmic web is eternal in the sense that it exists beyond individual human lifespans and even beyond civilizations. But it is not eternal in the absolute sense. It had a beginning in the quantum fluctuations of the early universe. It will have an end when dark energy stretches it beyond recognition. Between beginning and end, there is this middle time, the time of structure, the time when galaxies cluster and stars shine and planets form. This is the time we live in, the time of complexity, the time when the universe is interesting. Someday, the cosmic web will fade. The universe will become simple again, uniform and empty. But that day is trillions of years away. For now, structure endures, beauty endures, and you are here to witness it. That is enough. More than enough. That is everything. Thank you for taking this journey with me through the cosmic web. Thank you for your attention, your curiosity, your willingness to contemplate the vastness that surrounds us. I hope you found some peace in these explorations. I hope you found some wonder. I hope you carry forward a deeper appreciation for the universe and your place within it. The cosmic web will continue its slow dance through space and time, indifferent to our observation, yet profoundly meaningful because we can observe it. You are connected to it all, from the smallest particle to the largest structure. You are part of the web. You are part of the cosmos. You are home. Rest well, and when you wake, look up at the sky with new eyes. The universe is waiting to be seen, and you are exactly where you need to be to see it. Good night, fellow traveler. Good night. Our journey through the cosmic web has come to an end, but the universe continues its eternal dance. The filaments still stretch across space, the voids still expand, and the galaxies still flow along invisible highways of dark matter. You have witnessed the largest structure in existence and understood your place within it. You are not separate from the cosmic web. You are woven into it, connected to everything through chains of causation and composition that stretch back to the beginning of time. The next time you feel small or lost, remember that you are part of something vast and beautiful and organized. You have cosmic coordinates. You belong to the universe, and the universe belongs to you. What will you do with this knowledge? These are questions only you can answer. The cosmic web offers no instructions, only context. But perhaps context is enough. Perhaps knowing you are connected is all you need to find meaning and peace. Thank you for joining me on this journey through immeasurable heaven. May you carry the wonder of the cosmos with you always.